Good day, everyone. Terrence Walker and my trusted co-host, the incomparable Veronica Tafoya, here to deliver today's webcast as part of our Best of K-12 21 series, customized FCC calculations that anyone, yes, anyone can build.
Sorry. I have control now. This is teamwork at its finest. Hello, I'm Veronica, Ronnie Tafoya. And I just want to introduce, we're Argonaut Interel. Some of you, most of you, all of you know, we have created a company that is focused on helping our business partners and our clients reach their full potential. Our mission statement is basically to leave the world a smarter place than we found it. It's everyone that works at Interel. It's our own mission statement as well. And this Argonaut Interel gives us a larger platform to be able to provide a wider range of services to a wider range of companies. But Interel, Argonaut Interel, is still the same trusted partner that you have. We have with our ACE directors and our best-selling books, our Play It Forward videos, our wide range of services. We are the Interel, even though now we have a capital I, so the little I, but we are the same Interel. Oops. My mouse is very sensitive. I'm going to stop doing that.
Okay. The Net Promoter Score is a measure of how likely a customer is to recommend a brand, a product, or a service to a colleague. The industry average for systems integrators is 24%. The average for global systems integrators or our competition is 9%. Argonaut Interel's Net Promoter Score of 77% is indicative of our client satisfaction and the relationships that we form with our clients. World-class is simply our expectation, and every day we hold ourselves to this standard of excellence. It's our commitment to excellence that distinguishes Argonaut Interel from our competition. We're committed to building digital foundations that improve operating efficiency, improve agility, and improve operational effectiveness to not only propel our customers, but to enable them to become industry leaders. We are Argonaut Interel. We'll jump right into today's webcast with a brief introduction to Financial Consolidations and Close. What is it? Financial Consolidation and Close is Oracle's software as a service EPM tool that is purpose-built for addressing the financial consolidation and close processes. It is a configurable and upgradable consolidation solution that is no more than a pre-built framework tailored to address the most prevalent consolidations premises. It is truly an end-to-end consolidations process, given that it's not simply consolidations module. It also includes sub-modules for managing tasks, as well as also being able to integrate detailed data with the supplemental data module as well. As is the case with other like cloud-based EPM applications that Oracle offers, it uses or leverages Essbase as the underlying engine to produce powerful analytics and grand analytics and insights. The application also comes pre-built with a variety of hierarchies, calculations that no longer require customized definitions for those commonly used calculations, given that those are out-of-the-box features and our functionality. And one of the most prevalent wins when we talk about the transition from on-premise solutions to the cloud is that there is minimal to no infrastructure investment. When we talk about the application, the core definition of the application is based on the application's dimensionality. From an application definition perspective, FCC, as is the case with it having Essbase as an underlying engine, is a multidimensional database that literally includes a single application But within that single application, there are two plan types of databases that are leveraged within FCC. Those two being the consolidation, which is where the majority of consolidation processes occur, and the rates plan type if the election was made during application configuration to enable multi-currency. But the reality is there will always be a rates cube or plan type of an application. It's just a matter if we leverage that cube for performing translations or storing FX rates. Also, from a performance perspective, there are multiple types of Essbase databases. The grand win that we received from an FCC perspective is that we leverage the best of both database types, given that FCC leverages a hybrid enable application that leverages both block storage option functionality as well as aggregate storage option functionality to give us the best performing application in the world. And also one thing to also note for those folks who may be joining today is that given many people's ability to be able to access the underlying Essbase application or cube from a pure definition perspective to amend and address differing fashions for maintaining the application, given that it's a pre-built framework, that level of access is not necessarily available for FCC, but any level of feature functionality that will be necessary for maintaining or administering an application is more than available to system administrators. We're talking about the actual application dimensionality. There are a set number of pre-built dimensions that come with the application, but we have the wherewithal to be able to extend that dimensional definition based on the reporting need. Again, from an application perspective, given that it has two plan types, those plan types are specific to the actual purpose of the data sets that are maintained within. Thus, the dimensional definitions within the consolidations plan type and the rates plan type will be a bit different, given that the rates plan type only leverages those dimensions that are required for storing and performing the translations processes within FCC. We speak to a bit of additional definitions to how we would leverage or how the dimensions are referred to, given that the Essbase framework is basically cube-centric. The actual dimensions are primarily hierarchically defined or maintained, given that structures are the basis of the actual dimensional definitions. To that end, we have the wherewithal to extend the pre-built dimensional hierarchies to include those hierarchies or hierarchy sets that are required to better improve or reflect the financial reporting, as well as for those customizable dimensions, we have the wherewithal to define whatever dimensional content necessary to visualize or realize what reporting shall be from a financial reporting or analytics perspective. We're talking about the ease of deploying FCC. FCC, again, is primarily at its core a configurable application. We've got the ability to customize it as necessary, but at its core, it is a configurable application. The graphic that we're speaking to now speaks to the application wizard for developing the application's core content, or better yet, the feature enablements, given that as we go through and we're developing or defining the additional content areas for the use case or the purpose of the application, we actually define those feature sets or enablements here in the application creation wizard, where we have the ability to define the fashion that the balance sheet or the chart of accounts might exist, leveraging the journals module in the application, how we will manage intercompany eliminations in the application, as well as being able to define the core dimensions, better yet, the core custom dimensions that might exist in the application. And as FCC has grown, we found that Oracle's product development team has been more than gracious in offering new features and functionality to allow us to have a very comparable experience to the current on-prem solution to be able to replicate that level of reporting or that feature enablement in the cloud-based consolidations application. When we speak to the volume of dimensions in FCC, for those who've seen the on-prem solution, this is very, very similar, if not the same in many cases. A few different differentiators between the on-prem and cloud application might, one, be that the consolidation dimension is probably a replica in some fashion or some shape, form, or fashion of the on-prem value dimension, given that any data set that we can report upon on-prem, we have that same wherewithal in the cloud. We're also noting that from a peer reporting perspective, we spoke to earlier that the application does come with 2 plan types, and given that simple premise, better yet, when we're developing the application or enabling the application's features, we're also going to make certain elections. And in doing so, if we elect, as I mentioned earlier, to enable the application's multi-currency, then we will be able to visualize a currency dimension. If we opted to not enable multi-currency, the currency dimension still theoretically exists. It's just not visual for being able to add additional currencies, given that once we create the application, we're simply defining the application's reporting currency. So that would be the simple single currency in the application from a currency dimension perspective. We also have the wherewithal to enable intercompany. And our intercompany data aggregates an application. Again, that's more or less a feature enablement, as well as being able to leverage a multi-GAAP reporting dimension for having differing forms of reporting based on either local GAAP and or IFRS. And again, the reality is if we opt to enable the multi-GAAP dimension, that multi-GAAP selection then consumes one of the 4 custom dimensions that are available for FCC.
One of the ways that we can leverage Essbase functionality is by using member formulas. And what member formulas are just that. You can apply a formula within a member so that either dynamically when you retrieve that member, that formula will calculate, or you can have it be stored so that when you run a rule, the on-demand rule, then you can reference this account that has the member formula and it will calculate based on that formula. So what this provides is for, say that it's something you want to see dynamically, like the ratio, that would just be when you display it. You can use that in a calculation as well, even if it's dynamic, but it's just another way to leverage what Essbase gives us to be able to see more data. It also is something that you can use if it's really just a specific account that you want to calculate. Instead of having to build an entire script to do something, we could just stick that formula in this member, and whenever that member is called, it will calculate that. And by called, I mean either dynamically, or it can be stored and you can call that member in a script. If you have a business rule script and you list the member name, what that tells Essbase is run the calculation on this member. So if it's a stored formula, it will run that calculation. This gives us flexibility to be able to say, if this is true, then do this, otherwise do that. So it gives us a lot of functions that we can use and flexibility that we can use in order to speed up calculations and further our flexibility. And typically we'd put this on the account dimension, because it's stored and I'm sorry, it's dense. And so everything comes in to memory at one time and it's faster. You can also apply it to custom dimensions, but we do not recommend that you put it on the movement dimension. Although it's possible, it could impact performance. And here are some samples of actual member formulas that we've used, where in the member form, the member name of beginning balance backlog or BEGBAL backlog, we can have a member formula that says, if I'm in this month of this year, do this calculation. Otherwise, do a different calculation. And what this does is it shows you how I can use Essbase functions like previous sibling of the current member, which if I'm in FY20 would be FY19. And I can do the cross dim, which is like if I'm creating a tuple, then what it says is the intersection of data that is made up of backlog calculation December of the prior year plus the BBB seed member. So the cross-dim represents an intersection of data. If this is a true member formula, every other dimension, this would calculate based on every other dimension I'm in. So if I'm in a specific entity, it would calculate for that entity. If I was at the parent, it would calculate for that parent if it's dynamic. If it's stored, like I said, in your script, you could identify what other dimensions you want to apply this rule to, and then you call the member name, and it will run the formula. So this is some of the power that we get being able to use member formulas. And another sample is the same thing where we can do we can have nested if statements. You can, so with the member formula, it can be simply make this equal to this other account times -1, or just this other account. But you can get more complex in your logic with the if statements, or MDX and SQL, it's case statements, the same thing. And you can do these nested statements that say, if I'm not January of FY15, then do this formula of taking the prior backlog plus the intersection of orders and movement non-cash items minus the intersection of shipments and non-cash items. Otherwise, do the next if condition. So if it's not, if I am January of 15, then I want to look to see, am I opening balance? If so, do something else. Otherwise, be pound missing. So we can get pretty detailed in what logic is applied to these member formulas. And here are some that would typically be dynamic, where you would have, what is your EBITDA calculation? So this is wherever you are in your other hierarchies, it would calculate your EBITDA. And these are just EBITDA and EBITDA, which I know the difference, not being an accounting person. But so this is how we can do member formulas that would be dynamic and would calculate what we need to see no matter what level we're at.
Insertion rules, probably the most profound addition to FCC over the last few years, given that, as I mentioned earlier, at its core, it is a configurable calculation, but the simple advent of the inclusion of insertion rules has taken FCC to the next level and beyond, given our ability to now customize calculations within FCC. Our reality is that insertion point rules are part of, yes, part of the consolidations process. So whenever a user and or administrator opts to run a consolidate or translate rule, the content of insertion point rules are run as a byproduct of that process occurring. Insertion point rules are also part of the calculation manager functionality within FCC. And our reality is, given that Essbase is our underlying engine for FCC, the scripting content of insertion point rules is that of the Essbase scripting language. But Veronica has a bit of additional information as far as the ability to be able to create differing fashions or scripting options for calculations in FCC. Don't you, Veronica?
I do.
From a rules perspective, as I mentioned, the application comes with quite a few out-of-the-box calculations. These are fairly true to what we've seen on premise. Our reality is that there are different number of options for actually launching a rule. We can launch rules from the rule card. We can launch rules from a form. We can also launch rules from Microsoft Excel or leveraging the Microsoft Office Smart View add-in. So again, there are a number of pre-built calculations that are built into the application that perform specific definitions based on need. And we have the ability to augment that by including insertion point rules. So how do we access insertion point rules? There are a couple of fashions of doing that. From the navigation window, we can actually access the rules of the calculation manager under the consolidation feature under the applications cluster. We also have the wherewithal from the home page to access consolidations or the calculation manager under the applications cluster on the home page, which simply takes us to the exact same definition in differing fashions for accessing it. Once we've opted to access the calculation manager or the consolidations process, as the graphic intimates, there are three specific types of rules that exist in the application. The first being local currency, second being translated, and the third being consolidated. And each of those specific rule groups has a specific volume of pre-built insertion point rules for inserting customized calculations, as well as having specific points in the consolidations tree or consolidations hierarchy for where the results of said calculations will be reflected. To that point, we've referenced the three specific types or groups of calculations. We'll note that in the application, we have our insertion point rules 10 through 60, and each of those have a specific criteria for where they're actually included from a group perspective. As the graphic also emulates, any rules that run at local currency or within the local currency group will result in values being populated in entity currency, or in other words, prior to the effects of translations if translations are warranted. The translation group would be a rule set that would only produce a result at either the parent currency level or a varying level, depending on the hierarchical definition for parent level currencies for where corresponding results might exist. And again, this is also part of the leveraging the application from multi-currency perspective. But again, that is where the resulting valuations would exist within the consolidation dimension as a result of developing translated insertion point rules. And then our last rule group would be the consolidated, which is where we have a combination of rules that exist within that group. We have first the ability to be able to create configurable elimination rules to derive how we may be able to transition from the standard eliminations process to be able to create that FAST rule in application, as well as being able to create post proportionalization and post elimination rules in the application as well from a peer reporting perspective. A bit of a deeper dive into the actual rules themselves. As we mentioned, there are specific rules within the group. And again, to that end, within the local currency rule group, the 10 and 20 rules are there for specific purposes. The 10 rule is for crafting calculations that should be run after the opening balance carry forward for local currency values. And then the second would be any rules that we want to have run in populating a value post the opening balance carry forward and any other processes that might run prior to the invoking of the translation process within the application. The translate rule group, as we mentioned, actually performs calculations once data has transitioned from local currency or entity currency and to the entity's parent currency. From that perspective, we have the three different insertion point rules within the translated rule group. The first being for translations that are before FX calcs are performed. We also have a rule group for, an insertion point rule for creating rules after the balance carry forward for opening balance, that is. And then last, we have a insertion point rule for producing calculations after the FX calculations have been performed and also after the open balance carry forward has been performed for translated data evaluation. So again, very powerful in that we have differing points in the application for defining where translated evaluations should be populated as a byproduct of the consolidations process. And then lastly, the consolidated group includes, as I mentioned earlier, two specific insertion point rules, and it also includes a rule for configuring elimination rules. But again, from a pure consolidated calculation insertion point rule perspective, the rule 50 is specific to, as is the case for translated, we have the wherewithal to produce calculated values that are after the opening balance carry forward, post translation, post proportionalization, and post elimination, as well as being able to create insertion point rules after the opening balance carry forward, post proportionalization, and post elimination as well, if there is an election to enable ownership management to have differing forms of consolidations with having differing forms of ownership at an entity basis. When we speak to local currency rules, and again, here's a view of the GUI interface within FCC's calculation manager that speaks to those specific rules that I spoke to earlier. So again, the FCC 10 and 20 rules are reflected here with hyperlinks that actually take us into the calculation manager. But one thing to also point on the graphic that we didn't speak to earlier, FCC also comes with pre-built functionality for deriving the statement of cash flows. To that end, we no longer have to craft specific calculations or custom calculations for the most part for the development of the statement of cash flows. There is a rule that Oracle developed several months ago. Thank you, Oracle. That allows us to define or assign, better yet, a relationship between a statement of cash flows line item member within the application's moving dimension to a corresponding trial balance account from a reporting perspective. And by simply leveraging that member property enablement and assignment, better yet, at the account level, we're able to calculate movements for that basic relationship to trial balance account, the statement of cash flows member or line item from a movements dimension perspective in the application. And again, this is an absolute phantasmal win for developers in that this was a development that was a customization on-prem, and prior to the deployment of the calculate movements rule within FCC, this was also a custom calculation or a gap. And again, that functionality gap was quickly addressed by Oracle, and we are very, very indebted to Oracle for that inclusion. Here's again is a view of within the actual calculation manager itself, the listing of those rules, those insertion point rules, as well as the actual highlighting of those rules within the listing itself. From a translated rule perspective, the same premise that we saw from a local currency perspective, given that we have the wherewithal to see those 3 insertion point rules and their corresponding hyperlinks. There's also an indication for within the actual GUI interface, what would be a true insertion point option or means, given that there are differing icons that represent insertion point rules versus those rules that are configurable. That said, when we're looking at the translated rule group, again, there are 3 insertion point rules that we spoke to before FX calculations and then the final calculation. So again, this is our means for accessing them from the GUI interface. Once you select the corresponding hyperlink, it is then going to transition us into the calculation manager, which is where the actual magic, quote unquote, happens for developing those custom scripts for producing those results based on a requirement for reporting. And then last, within the rule group, there are 2 insertion point rules, the after opening balance carry forward and the final calculations. And then there is 1 configurable calculation definition, which is where we are leveraging the configurable functionality from a rules deployment perspective for being able to configure eliminations or non-standard better eliminations logic within the FCC application. Again, here's a view of those last 2 insertion point rules that are part of the consolidated rule group within FCC. Here again is a view of a bit of syntax or that calculation manager view within one of our insertion point rules. Again, the reality is that any calculation manager functionality that would have been available on-prem is still available within the cloud. From a pure function perspective, not all functions are currently available for FCC, but that is a ever-evolving premise, given that each month we're finding that Oracle is making available additional functions for FCC applications to further extend the pre-built framework for the application. Couple of things to note when we're talking about simple rule enablement or rule deployment application. There is a requirement that within the rules that we validate our rules in the application. We do have some options for how we can elect to undeploy, quote unquote, rules by either electing to comment out rules or to remove them altogether. Our reality is once we've elected to deploy our rules from the calculation manager to our actual application, the corresponding calculation status is going to be impacted by said rule deployment, which may require a subsequent consolidation translation process being run in the application to visualize the effects and or the results of the updates to any calculations that might exist as a result of redeploying our rules. And here's a view of, again, a bit of script in the application. We'll speak of this in a bit more detail in the coming moments. But again, from a pure definitional perspective, you'll note that the premise for calculation definitions is a bit tangibly different than that on-prem, given the Essbase scripting language. But for all intents and purposes, the literal deployment or that transition from on-prem rules to FCC cloud-based rules is not that tantamount of a pivot. Our greatest reality is, in our experiences in migrating applications or transitioning from on-prem to the cloud, is that in most cases, we're finding that 75% of the rules that we had to create as custom calculations on-prem are now out-of-the-box calculations in FCC. Veronica?
Okay, I'm going to go back really quick. We're going to talk about some real basics for Essbase calculations. And I do want to kind of go back to the script that Terrence was showing to be able to show what I'm talking about. One of the things to know within the FCCS insertion rules and the on-demand rules is different than how Essbase or planning works. There you are living within a box in the sense that there are black box you can't see, but Oracle does, main big outer fixes. And what you're doing is inserting logic is in the insertion rules in very, very specific parts of a larger rule set that runs. And even with the on-demand rules, you're still living within certain dimensionality that Oracle has put around us. So in one sense, we still can use Essbase functionality. As Terrence said, not all of the functions are available, but more being added as Oracle can make them work within, like I said, their predefined framework. A couple of things that I noticed in Terrence's script is things like using fully qualified names, which is an Essbase feature when you enable the to be able to have the same alias in multiple aliases and multiple members and things like that. What I want to talk about really quickly, though, is the idea of a fix and an end fix versus an if and else if. With a fix, what you're doing is you are narrowing the scope of what you're going to calculate. The way Essbase works is if you don't tell it what dimension you're calculating, it assumes the formula applies to every member in that dimension, which we know we wouldn't want to do. And part of that is why Oracle creates these outer fixes so that you can't get too lost. And what happens is if you're calculating a formula on every member of a dimension, you're going to create unnecessary blocks and it will slow your performance down. And so that's kind of why Oracle gives you the little bumper rails. But within those bumper rails, you can still narrow down what you're calculating even more by doing a fix and an end fix. Some of the things just to know as basics is you typically want to fix on a sparse dimension, because what Essbase does is it goes to the index and it says, oh, I need to do something on these members. Are they there? And it'll look in the index. So by doing a fix, it tells Essbase to go to the index and find that block and bring it into memory. In FCCS's case, only the account dimension is dense, everything else is sparse. So you're going to want to be able to fix on as many dimensions within those guardrails that Oracle has already put in place that you can, because it's faster. So that's one of the things that fixes and end fixes can do. The other thing is that it can have, like, you pull out, I just see it as kind of like getting ingredients to make something. I can pull out a whole bunch of ingredients, or I can pull them out a little at a time, right? So if I'm going to make a rub, I might want to do my herbs first, and then I'm going to bring my salt because I'm going to combine it together. Fixing and end fixing allows you to do that type of nested processing as well. Just really basic things. If you have a fix, you have to have an end fix. You'll get an error when you try to validate it. The errors aren't always really indicative of what the problems are. But if you have a fix, you need to have an end fix. What we typically do is we indent our nested scripting so that it's easier to see if you're missing an end fix. Here's an example of what a fix, and when I talk about nested fixing, is my outer fix is I'm fixing on East region and West region. So whatever I do is going to happen to both. Then I'm fixing on actual. So it says, okay, actual East, actual West, I'm going to calculate the member formula in the member op income. When we talked about member formulas before, we said if you actually just list the member, if there's a formula attached to that member, it will run. So that's what this is doing. And then once it's done with actual, it does an end fix, and then it fixes on budget for the same East and West region. And then it's going to calculate the formula in margin. So that's a very simple example of how fixes work, how I can have my big fix, I can narrow it down even more, end that, and then do something else somewhere else. Something to keep in mind, though, is when you're doing your nested fixing, if you don't have an end fix in between, it does an additive. So I fix on actual, and then I fix on budget. I'm actually going to run something on both. So going back to this one, if you want something different to happen, you're going to have to make sure you have an end fix in between. Otherwise, if I said fix actual and fix budget and then op income and margin, it would run both formulas for both scenarios. And that's not what we're asking it to do. So that's something else to keep in mind. If statements, like we said in member formulas, allow you to add conditions before something happens. This is typically slower than running a fix, which is why if I wanted to calculate the op income on my actual and margin on my budget, I wouldn't fix on both and then say, if I'm actual, do this. Otherwise, look, if I'm budget and do this. What happens in the back end is Essbase runs a pass through the database looking for the condition. And then it runs a pass through the database looking for the next condition. Whereas if I say fix on this, it knows exactly where to go. It knows exactly what to do. It lets go. So that's the thing between an if and a fix. However, a lot of times you need to have that if condition so that you can do different things depending upon different intersections or different conditions that are being met. That's what if conditions are for. Oh, I know. I really quick. I want to go back to this script and point out a couple of things. So you'll notice that we have, we're fixing on a specific formula function saying, if my account has a UDA of RF Auto, those are the accounts I want. And then you'll see where the next line says FCCS no intercompany, and there's an open parenthesis. That's what I call a calc block. It's a member block. In Essbase scripting, BSO scripting, you can only have if conditions within that kind of member block. So you'll see where if you just try to say, if the member is this, do this, you'll get an error. So you have to create that member block in order to apply if conditions within a script. You don't have to do it in the member formula because that member formula lives in a member. What this is doing is it's kind of tricking Essbase into thinking that that's actually a member formula. So that's just some of the basics. And then the other thing you'll see is, like I said, if you have these little arrows, that is representing an intersection of data that you are either going to populate or you're going to get data from in order to populate. And this little trick about having cross dims to the left of an equal sign is a way to build blocks. So one of the biggest things that is a problem in FCCS is block creation. And Terrence has really mastered this in the FCCS world, but it's still, it's always a question, how do I create this block? Because once again, if the block isn't there, Essbase's index can't find it, it doesn't know what to do, it can't do what you're asking it to do. So that's kind of what I wanted to talk about.
Thank you, Veronica. I'm going to expand upon that exact same conversation in the coming moments. But as far as a comparison between the on-prem Hyperion Financial Management solution and the best thing in the world, Oracle Financial Consolidation and Close application in the cloud, there are some salient differences between the application's core feature functionality definitions. Granted, reality is, as the graphic emulates, is that FCC, for all intents and purposes, is a primarily pre-built framework or solution that carves out or alleviates the necessity to customize the application in a number of fashions. And to that end, we find that we have achieved optimal performance given that a number of these definitions are out of the box features and functionalities. Our reality also is that in this comparison, you'll also note that for the primary reality is there isn't a feature or an operation that we can perform in HFM that we cannot in some shape, form, or fashion also performed within the cloud within FCC. Also, we're making note that literally from a little content perspective, those primary customizations that we develop on-prem are pre-built, but we also have the wherewithal to extend certain areas of feature functionality definitions in FCC from a calculations perspective, leveraging our insertion point rules, or even to steal Veronica's thunder. We also have the ability to also create on-demand rules, which also existed on-prem. That feature set or functionality also exists in the cloud with FCC as well. Now, from a pure calculation comparison perspective, I have an example of a calculation that was performed within HFM and how we have pivoted this to being a calculation within FCC. You note that there is a collection, there is a reference better yet to an if-then condition. There is also a dynamic member list that has been crafted, as well as having a for next loop with varying calculation components that are defined within the application to produce a result within HFM. One of the first questions that we always receive from clients who are pivoting from on-prem solutions to FCC is, can FCC perform this calculation? Can FCC do this? To that end, without fail, I and my team have been very, very successful in transitioning calculations that are warranted. I'm not a big fan of creating calculations for the sake of creating calculations, because I'm a huge proponent of optimal performance, and I'm also an even larger fan of keeping things simple. To that end, we were able to transition this calculation into being a calc within FCC. And as a callback to some points that Veronica made earlier, there are a series of fixes and inner fixes in the application. You'll note that we're actually leveraging a fix on a user-defined attribute for accounts that are referred to as RF Auto. We are then anchoring, or that member block that Veronica spoke to, on a specific sparse dimension member. And then we're leveraging the calc mode function, the bottom up, that is, feature of calc mode to help us in optimizing the performance of the calculation. We're then leveraging Essbase calc scripting language to bring this calculation to life, and that we're literally ifing on members within the year dimension, but we're leveraging our siblings, or be the right siblings of FY21. So this calculation is only going to run on FY21 and subsequent years. We're also ifing on specific members from a relative perspective of a upper level parent and a specific base level member. And then it's kind of funny. I've had different conversations with people determining if I need to include the if statement on line 8, since I'm fixing on line 3. But here's my reality. When I remove the if on line 8 from the calculation, this may blow your mind, it actually took longer to run with the if removed than having the if included. So again, I've had different sparring matches with different folks at our firm and different friends that I have in the market, just talking about the necessity to include that. And my reality is I've tried in different fashions to determine if that if is warranted from a performance perspective. And I found that it was actually an improvement. Again, it may be an anomaly, but I'm a big fan of improvements, optimizations, so we kept it.
And
now,
I just want to interject really quickly to say, this is the art of building scripts. To that point, no, technically you don't need it, but it runs faster with it, keep it, right? And that's what we learn as developers.
Yes. Now, the one point of angst that we probably experienced early on when the premise of insertion point rules was introduced was the dang premise of creating blocks. So why do I have to create a block? Because in HFM, I just can actually calculate anywhere in the world. Conversely, with an Essbase, given its cube nature, I have to create a block to be able to populate data valuation. To that end, by leveraging the create block function and referencing a sparse dimensional member, we have without fail been able to create calculations and populate values where there would not have been a block created prior to. The calculations run by simply leveraging simple Essbase calc scripting logic and syntax, we were able to produce values where necessary without having to jump through hoops, which is a grand win for everyone involved because that was a big hoop that we had to jump through. So from that perspective, we had
just to
Right.
insert again, I'm going to insert into this insert role now, is what I like about your create block is that you're creating a single block. One of the reasons why we don't always want to use create blocks in a bigger script is because you could potentially create many more blocks than you need, and it does take time to do it, what Essbase does behind the scenes. So you're making this efficient, and I want to call it out because this is how create block is supposed to work. You're referencing an intersection of data, you're creating a block or a few blocks, because it's basically if you had multiple in your first fix or something, you're really focusing what you're creating. That keeps it fast.
Yep. And once we transition from the block creation, we then have a if, else, if, end if, where we're simply ifing on members within the data source dimension because there are different calculations based on the different segregated data values within our data source dimension. And then we wrap our calculations up with our end ifs and the corresponding end fix that's associated with the outer fix that's part of, excuse me, the insertion point rule that we would amend it to include additional members to further refine our calculation for optimization purposes. As far as configurable calculations, again, the application does come with, within the consolidated rule group, the option to create differing forms of configurable calculations. We'll speak to one now, given that we have the wherewithal to produce translation overrides. And again, this would be a fashion for having a non-standard translation rule exist in the application. In this example, we've opted to create some form of reporting, maybe from a restatement perspective, or depending on how you define a restatement as a recast. We want to see data normalized from a financial reporting perspective, leveraging the prior year's rates for current period data. So again, that will remove the effects of FX. So we can simply create a configurable, yes, configurable, not customization, translation rule in the application by simply selecting the appropriate operands for producing a result based on our need. And in doing so, within the actual interface is simply a series of elections to further define this translation override rule, defining the corresponding translation method, be it periodic, year to date, then the corresponding definitions from a race perspective, given that we just can elect the specific rate that we want to include from a specific scenario, and or leveraging out of the box definitions for operands. In this case, we've opted to take the prior year's FX rates, and we're going to use those to translate data in the current period in the lower graphic of this corresponding caption. Once we made that definition as far as setting our rate information, we then define the corresponding redirect definitions from a member's perspective. And the simple magic happens in the application as a byproduct of simply developing this fashion of translation override to further extend the reportability of data within the FCC application.
Whew, that's a tongue twister. Okay, moving on to on-demand rules. So this is a newer feature, and it gives us flexibility to do more creative, customizable calculations. So when Terrence had the slide that showed this is custom in HFM and custom in allocations were listed, allocations is a perfect contender for an on-demand rule because it's something that can be run outside of the consolidation. And that's key for what our on-demand rules do. We can attach them to forms. We can have them be launched by someone doing a rule or within tasks. There are multiple ways that we can do it, but the keys are to know that it happens outside of consolidation. If it's something that doesn't have to happen every time you consolidate, right? Typically, you might allocate only once everything is set. You can pull that allocation script out of the consolidation, which reduces your consolidation time. So that's another benefit of having an on-demand rule. Of course, there are rules with our rules. So the rules are that, once again, Oracle is giving you your guardrails, and it creates an outer fixed parallel that you don't get to see. And within those within that fixed parallel are 6 dimensions that are required. And the way that Oracle makes them required is they give you a runtime prompt. So the runtime prompt allows the user to either populate it, or if the rule is attached to a form, you could have the data on the form drive what the runtime prompt is, but you will have to identify scenario, year, period, entity, currency, if it's enabled, consolidation. You will have to choose a member, and within consolidation, you can only choose the entity input, translated currency override, and rate override. And if you want to use the amount override, there's a substitution variable that you have to create and enable. So it's something that, once again, the guardrails look for to allow you to use those members. These members have to be populated, but they are not members that you're going to add to your fixes. So it's just something to keep in mind. There are guardrails around this. The intercompany elimination member is not available for on-demand. So that's just something else that we need to be aware of. This is an example of what that on-demand rule looks like when you open it, when you create a new rule in Calc Manager, different from the insertion points where it has predefined scripts and you can put your code in, or as Terrence said, if you want to back it out, you delete all the code and redeploy, because that is part of a bigger set of scripts that runs. This is more on its own. It's the on-demand. And when you create a new one, you'll notice the variables are all set and they are all required. This little trick allows you to preset it if you want it to. And then if there's a override value, you can hide it so the user can't see it. And then you can override the value, even if they did insert something, or if you have a variable that has a default value and you want to override that default, you have the option here, but all 6 dimensions have to be accounted for. And then you can just create your script based on what you need to be able to do. So in this example is just kind of showing how I'm fixing on different dimensions, and you don't have to split them out this way, but you can. So that's kind of the beauty of writing a script to make it readable. Essbase doesn't care if there are carriage returns in between members, because when it translates, it puts it into one long line anyway. But for usability and readability, you would probably want to split it up that way. And as you're becoming familiar with the dimensions, or if you're turning this over to someone else to maintain, having what dimension is there that you're fixing on, that's a good practice too, because I've come into clients and not understood the data, and then all I have is a list of members, and then you have to do the investigation. So it's also nice to be able to tell them what dimension. If you build a rule and you want to launch it, there is a rules card in the navigation, and this is where you can launch the rule. You can also, as an admin, apply the permissions to who actually gets to launch the rule, but this is where you would do it. And then when you launch the rule, it pops up with the runtime prompts that you have to populate. So the 2 that were hidden don't show up. You can also change the order of how they show up, but this is how you would launch an on-demand rule. And when you create the on-demand rules, you can use all the Essbase functions, except for the ones that are not allowed in FCC. But so you can use the tech reference to get information on the functions and how they work and parameters and things like that. And Groovy, which I'm not a Groovy expert, but I'm learning more and more, and I am seeing the value of having Groovy. And within the May release 2105, Oracle allowed Groovy within to FCCS. And one of the things that came right off the top of my head is, if you're now allowing users to enter data in a form, if you save that data and the order it happens is save data, run rule. So if there's something wrong with the data that I saved and the rule catches it, it doesn't unsave your data. You would have to make a custom rule that would clear out the data. It gets messy. It can be confusing. Users will save, they'll see that data in the form. They think the rule ran successfully. A Groovy rule you can launch before you actually save the data, and it can do validations to say you're not allowed to save this because this is out of range or you're missing this or something like that. You can code in Groovy what those validations are. It prevents the save until they fix it, and then it'll save and you can run your rule. Another key thing is to be able to launch REST API calls, and I'm going to show you an example of that. There is the REST API documentation as well as the Groovy docs, and the Groovy docs get updated as Oracle adds additional methods. So Oracle takes everything Groovy can do and condenses what Oracle allows Groovy to do, and that expands as they're developing. So that Groovy doc is always going to be updated. Just really quickly, because we want to leave time for some questions, is if I'm going to create Groovy rules that use REST APIs within FCCS, there's the ability to create connections. The example I'm going to do is FCCS is consolidated. We're ready to push the data to planning so planning can run the rule that creates their drivers and trends for forecasting. What do I need to do that? One, I need to create a data management connection, which is this one, so I can run a data management rule. The other is to create a connection for planning so that I can run a rule within planning. And this is some Groovy code. So this code here monitors data management to say, I launched my rule. I'm not going to do the next step until that rule is done. So this is just setup. I have used it because other consultants smarter than me have tested it and created it, and I know it works. It's plug and play. No matter what environment you're in, it'll work. And then when we want to run the rule, we're creating what is the start and end date for my data management rule based on what is my current period, because that's what I'm going to push over. And when you do that, the launching of the rule is very simple. It's just a REST API call that says, I'm running a data rule. This is the name of it. This is my start and end date. And I want to replace it in Workbench and export it out and store it. This is also plug and play. You changed your connection name. I always make my data management's DM so that even that is plug and play. And then you update what the rule is. And if you're doing variables for the start and end date, this is the same process. But once I launch my data management rule and it's over, I'm going to now run a rule that calculates my actuals in planning that does all my trends. So this is just an option of now FCCS, instead of having to send an email saying, okay, we're ready to push data, it could just automatically flow through a Groovy rule that does multiple steps. And something else that we did with planning, which I think would be helpful in FCCS, is this block creation issue. We use Groovy to get around that because there was really no way other than someone inserting a 1 to create a block. But with Groovy, I could say, here's a group of data. This is a group of rates, somewhere completely different, and I'm putting my results somewhere completely different. And Groovy was able to do that for us. So we have 3 minutes. And that's our little how Groovy can help FCCS.
Sure. Thank you, Veronica. As a means of recapping our conversation, our reality is that FCC is based on optimal dimensional definitions and developing efficient calculations. Our reality is that since the application is a prebuilt framework, these should be maintained or part of our expectation. We're developing these applications given that we are very, very succinct and working with our clients and dimensional definitions, and more focused on ensuring that we're creating necessary calculations within the application. To that end, we are more than empowered as a firm to develop the most optimal calculations given our background and the resource demographics at Interrail or are going to Interrail better yet. So we're more than capable of crafting those optimal calculations to further improve calculations with the FCC. We're also incented to craft rules with an FCC from an insertion point perspective based on need, as well as being able to craft member formulas of that fashion of rule that won't have a negative impact on performance. From a consolidation perspective, also indicative of Ronnie's part when it came to speaking to leveraging on-demand rules in FCC. And as a callback to that point, I didn't want to interrupt her, but it's actually pretty funny. We've actually developed applications in FCC. We've actually created allocation methodologies that were pretty phantasmal. And those allocation methodologies, to Veronica's point, were developed by leveraging on-demand rules. Our greater reality is, given Oracle's enterprise licensing premise, the majority of our clients, probably 90 to 95%, if not more than that, are leveraging the enterprise licensing model. So that was a one-off. What we're finding is, from an allocation methodology perspective, there are purpose-built applications for handling allocation methodologies. So that expectation or realization of creating allocation methodology with FCC, while we can do it, is probably not the best place, because there are more purpose-built applications that handle that type of functionality from a calculations perspective. Also within the application, as we spoke to in with our prior graphics, the majority of calculations that we develop as customized calculations on-prem are no longer warranted, because those are pre-built out of the box functionality definitions with FCC, which is simply a win from the perspective of creating a more simplified application, and a client win when it speaks to ownership of applications and not having to manage or decipher complicated scripting logic with an application from a customizations perspective. And in wrapping up, as Veronica intimated, with the ever-evolving evolution or the addition of Groovy from a scripting perspective in FCC, the sky is literally the limit from a calculation perspective for developing differing fashions of calculation, leveraging both the Essbase calc scripting language, and for developing calculations leveraging Groovy from a scripting perspective. That said, from an upcoming webcast perspective, today, thank you guys for joining our custom FCC calculation webcast and our upcoming webcast series. On the 11th, we will embark upon a 4-part series from a manufacturing transformation perspective. We'll then transition to said webcast related to Groovy on the 18th of August. And then on the 25th, we'll embark upon our webcast relating to the future of enterprise performance management. That said, we are at the top of the hour, and what I think we'll do, Veronica, is, given that there were some questions that were posed in the Q&A, what we'll do is we'll take that repository response to those persons who submitted questions and get those to them, to be mindful of time. So that way we will make certain to respond to questions and to ensure that any knowledge that Veronica has or that I can impart to those folks asking questions, we'll make it a point to get that information on to them.
Okay.
So with that,
perfect.
I would like to thank you, for myself and Veronica, for attending today's session. Again, we apologize for going a bit over, but I think that the content that we delivered might have been very, very pertinent for some and may have been a blessing to others. So with that, I bid you guys a grand adieu. Have a great day. Until next time, this is Terrence and Veronica signing off. Thank you guys. Have a great day.